What I wanted to do in this video is give you a chance to take a look at another chemical reaction and try and see if we can figure out, is this a redox reaction? And so in order to do this, we're going to work our way through this entire thing, and we're going to calculate the oxidation numbers of every single element, both as a reactant and then as a product. That should always be the method that you undergo when you're trying to determine if something is a redox reaction. Now, if we're taking a look at barium nitrate, what I would do if I were you is split this into two separate substances. Look at it as barium, and then look at it as nitrate. It's just a much easier way to be able to understand what's going on in these two substances. So barium's easy. It has an oxidation number equal to its charge, so its oxidation number here is going to be +2. Now, nitrate, we can break this down like we've broken other examples down. If you're at the point when you don't need to do it this way, if you can just calculate the oxidation number, awesome, go for that. But for those people who are struggling a little bit, I wanted just to make sure we lay it out really clearly. So take a look at the number of atoms. So 1 nitrogen, 3 oxygens. Take a look at the oxidation numbers that you know. -2 for oxygen and unknown for the nitrogen right now. Totals, well, we know that 3 atoms with oxidation numbers of -2 gives us a -6, and we know that any polyatomic ion has to have an oxidation number equal to its charge, or sum of oxidation numbers equal to its charge. So that means the nitrogen, well, the nitrogen has to be +5. And since there's only 1 nitrogen, that's divided up amongst the 1 nitrogen. So that means nitrogen has an oxidation number of +5. Let's just move this over here. And then the oxygen has an oxidation number of -2. So we figured out one compound. Let's take a look at the other, and let's do it the same way. Now, I know this is going to take up a lot of space here, but in the end, we're actually not going to need a ton, and I'll explain in a little bit. But whenever you have a ionic substance, it's much easier to break it down into its component ions and look at the oxidation numbers using charges. So that means sodium has an oxidation number of +1. Then the hydroxide, well, oxygen has to have a -2, hydrogen has to have a +1. You add those together, and you're going to get that -1 as the total sum. So oxygen is a -2, hydrogen +1. But then I want you to take a look over here and see what we've got. Notice NO3. Well, NO3, the oxidation numbers of each of those substances isn't going to change. NO3 is no different whether it's paired with Na or whether it's paired with Ba. It's still NO3 with a negative charge. So that means oxygen has a -2. The nitrogen, its oxidation number is a +5. Now, sodium, we can figure this out by breaking it apart. And sodium would be a +1, and then you'd have your NaNO3 -1. So that means the sodium has to have an oxidation number of +1. OH, well, OH is no different than when it was over here. O -2, H +1. If you were to break this apart, you would find that you'd have Ba2+ combined with your OH-. So that 2+, there's your oxidation number. Okay, so here's what we really need to do now. Let's take a look at the oxidation numbers from each substance. Barium goes from +2 to +2. No change there. Nitrogen goes from +5 to +5. No change. This oxygen, -2 to -2. Sodium, +1 to +1. This O, -2 to -2. H, +1 and +1. Here's what we've learned by doing this. This is not a redox reaction. If there is no change in oxidation numbers, then it's not a redox reaction. that is how we can actually tell if electrons are exchanged or not. So there we go. One thing you may notice too, this is a double replacement reaction. You have Ba and Na basically swapping partners, what they're bonded with, leading to these new products. This is my other little tip for you, is that a double replacement is not a redox reaction. Now, there may be a few cases where there is an exception, but I have yet to find what they are. And so it's kind of a good rule of thumb if you see a double replacement, just to have your heads up and be aware. It's probably not a redox reaction, but you should always check by figuring out your oxidation numbers. So I hope this extra example helped, and I will see you next time.